Mastering the Art of Attacking and Defending a Kubernetes Cluster. Sanjeev, Mahajan. Thank you.
All right. I hope you can all hear me okay at the back. Give me a chair if you can hear me. All right. Thank you. All right. Thanks for joining me on today's session about mastering the art of attacking and defending a Kubernetes cluster. I really appreciate you all coming here and spending your precious time with me today. We'll be talking a lot about attacking and defending Kubernetes cluster, as the name says. Quick introduction about myself. My name is Sanjeev Mahajan. I'm currently working as a principal security engineer with cyber services. I've been in industry for more than 15 years now, and started off as a system admin and moved into world of security, which I've been doing for the last 10 years. For the past few years, I have been heavily involved in the world of Kubernetes, both as an attacker and defender. It has been a great journey. It's been full of learnings and a lot of challenges. Unfortunately, I only have 25 minutes today. I won't be able to cover everything, but what I'll do is I'll try to cover the maximum, the significant learnings that I have gained over a period of time, and always I'll be in the hallway to chat more after the talk. So that brings us to the agenda of today's talk. We'll be talking about what is a Kubernetes cluster, common myth when it comes to your security of Kubernetes cluster, and then talk about my favorite section of today's talk, which is the attack chains on the real world Kubernetes environment. And then move into the world of defense in depth strategy, which is for my security champions who are the defending champions. We'll look at some of the controls and tools that can help us defend and secure our clusters, and then conclude with key takeaways. Before we jump into the technical stuff, a quick disclaimer. I will be referring a lot of project teams, especially DevOps and product owners, throughout my presentation talks and referring them. By no means I'm here to disregard or disrespect any of them. I love them all, and they have been a great, like when it comes to learning the Kubernetes world and the cloud stack. So no disrespect to them. And then I'll be referring a lot of security tools, both open source and commercial, in my presentation. By no means I'm here to endorse any of the tools. They're only for reference purpose. And then the examples and the list shown in my presentations are not exhaustive. They are only for reference. I've only picked up the most significant ones that could be of your use. All right. So enough of talks about the disclaimers. Now we'll jump into the world of Kubernetes cluster. So what is a Kubernetes cluster? The first thing. So if I were to explain technically, it is called as a container orchestration tool. Now, it's too technical, right, and it doesn't make sense. But if I were to lay it down simple terms, it is like a set of machines working together to deploy, manage, and run your containerized workloads. Still technical, right? Let me make it more simpler. I like to call it as a party planner for your software. Now, why do I like to call it as a party planner? Because just like party planner, Kubernetes takes care of everything for your containerized workloads, so you as a developer or the project teams can spend most of your time focusing on building great softwares. So that's the Kubernetes cluster for you in simple terms. Now, but what with great responsibilities comes great risk and comes a lot of confusion. When I was I was working on Kubernetes clusters, engagements, and in my research, I saw that there were a lot of confusions prevailing in the industry when it comes to security of Kubernetes cluster. And the most significant ones were, like, when we were talking to the teams, the project teams and DevOps, they were saying, like, Kubernetes, it's all secure by design. And another thing we keep on coming to us was that the cloud service provider like Amazon or Google, they're responsible for maintaining security of the cluster. Now, let me tell you that that's not the case. It has always been, and it is a shared responsibility model. Now, what does that mean? It means that when it comes to Kubernetes cluster security, the role or the remit of the cloud service provider is only to make sure that they have control over the physical security of the containers or the physical machines like data centers. They are responsible for securing that. Whereas every other thing like configuration of the cluster, where, for example, your network policies, your IAM controls, and also your data storage. That all relies, and that is under the remit of the customers or who are using Kubernetes. So basically the configuration of the Kubernetes. And based on our experience, based on the research and the engagements performed, we have seen that 90% of the findings comes due to the misconfiguration of the clusters, because it's not secure by default, and people assume that. Other common myths and illusions we identified during our interviews and sessions with the tier 1 organizations were that we don't need offensive security assessments happening on Kubernetes cluster. There's no value add of such engagements. In later slides, I'll show you the attack chains and show you how these the offensive security assessments are so important on clusters, and we'll talk about it in later slides. All right, so moving into my most favorite section of today's talk, which is attack chains. So these attack chains were performed on the real world environment with Kubernetes clusters as their hero champion or the hero component, and they were, and the best part was that when we were attacking or we were performing these engagements, the clients, they had already mature practices in place. They, like when we were doing the prep work or the scoping, the clients informed us that we are already we have a bunch of a fleet of security architects and engineers who are doing hardening on day-to-day basis. So the summary of these attack chains is that we were attacking a pretty much mature and locked down version of Kubernetes clusters. Let's see let's see the details of the first one now. Unfortunately, I'm not going to run any demos today because I've been burnt a lot with the live demos, and these were specific, like you can't replicate these environments because this is not a lab environment. This was found in the real world, so there is no assumptions or there is no lab sort of environment. So we'll talk about details of this. So the first one was we were talking to a client. Again, this is a tier 1 client with mature practices. The first thing client says, hey, we have everything that is required to secure the cluster, and when you are going to do this engagement, please don't give me any findings on the non-production environment. Please give me findings in the production environment only, because anything is non-prod, I won't consider it as a finding. So that was the first challenge put in front of us, and second challenge was that how far can you go when you have a limited access in my environment with like a read-only user, and can you do that? It's like almost like doing a red teaming for them on the cost of an internal assessment. All right, we started our reconnaissance with full force. We wanted to prove that the client that we are going to give you some value add. It's not just about the money, it's about some value add given. And what we saw was, while doing the reconnaissance, the client was pretty much right. It was so properly configured. The Kubernetes, we have seen one of the best configurations the client could ever make. There was nothing misconfigured, and the client had all the security controls in the Kubernetes, almost like next to impossible to crack anything, and we were almost going to end up sending a vanilla report saying that, hey, you are doing amazing work, and we couldn't find. But we did not give up. What we saw was during the reconnaissance process, we looked at every possible integration and every possible configuration. The interesting thing we found in that reconnaissance process, was that there was a single pod running out of like a millions of pods, or the pool of pods that was running with a cluster admin privileges. Now, the cluster admin, for those who don't know, is like the cluster admin privileges are, you can basically create any pod inside the cluster, or you have permissions to create or laterally move into the cluster. So if you have the credentials for that pod, and we knew that the credentials of that pod live in the memory of the containers of that particular pod. So if we were able to somehow get access to that pod, we will be able to compromise the cluster, and it will be like a great finding and win for us. So now we knew that we have to go after this pod, but how do we do it? We had no clue, because it was sitting securely in the cluster. So what we saw was, because the cluster was not giving us any movement or anything like we could attack, we started looking into the integrating assets. And the best thing we saw was there was a CI/CD pipelines that were configured, and they were provisioning assets into the cluster, both prod and non-prod. So what we saw was that, again, in the series of the CI/CD repositories, there were a bunch of CI runners they were running, and one misconfigured runner caught our attention, which was running with a permission that is called as get secrets. Now this is because I'll tell you in details about, I'll tell you how this was misconfigured, but for now, this get secrets permission, that runner was allowing us to get secrets into the production and non-production environment, and we had to somehow get CI runners access token. Again, how do we do it? We had no clue, but we knew that there is a way to do it through running an exploit on the repository. So we started looking into the repository. Thanks to the naming convention that CI runner, we got to a repository which was running that runner. And another misconfiguration we saw was that the runner could be configured in a way that there was this repository could, anybody on the network could create a feature branch and on that repository. And what we just exploited that, we wrote a simple script, like a Python script, and we kind of extracted the access token for that runner using the metadata APIs. And there it was. We had the access token of the runner who could get secrets for the pod which is running in the production cluster. So the best part was we got the runner token, replayed it, and got the secrets for the pod that was running with cluster admin. And that's how, guys, we were able to compromise the entire cluster. Now, the best part about this attack was the reason that developer or the engineering team gave get secrets to the runner was due to the naming convention confusion. In Kubernetes, you have two permissions, get secrets and list secrets. List secrets allows you to only see the metadata of just like secret name, no value add in terms of when it comes to attacking. Whereas get secrets lets you see the actual value of the secrets. So the team was confused between get secrets and list secrets, and they had confusingly given get secrets permission instead of list secrets. And that's how we were able to exploit that slight misconfiguration of get secrets and compromise the entire cluster. So when it comes to Kubernetes, the slight misconfigurations can create significant impacts, is the message from here. Now, we just saw how we were able to compromise the entire cluster, starting from a read-only user, from slight misconfigurations in the CI/CD ecosystem, and also attacking the cluster from the CI/CD ecosystems. Now, the next target given to us was from another client saying that if now we understand you're able to compromise the cluster, what if in my case, this scenario was that can you break out of the cluster and get read and write access to the storage buckets which has sensitive data sitting there. Another challenge, interesting thing, and we started with our standard process of reconnaissance, and we saw that on the surface, as always, it was looking pretty perfect. We had no access from the non-production cluster to the storage buckets, especially the production buckets, and we wanted to get a read and write access to production storage buckets. That was the task and the challenge for us. So we started looking into the configurations of all the pods and the service accounts, and what we saw was out of, again, there's so many, like millions and thousands of pods running, and in one pod there was a storage admin permissions configured. Now we saw, okay, it's not a big deal, you can have storage admin rights given to a pod, but what we saw was, again, that this pod particularly had storage admin rights on non-production and production. I'll tell you why it was the case in the later slides, but what we saw was like we knew that once we get access to this pod, we can then craft our attack towards progressing towards the storage buckets, getting access to the storage buckets. So what we did, we got an exec to that pod because it was running a beautiful shell, and once we had the shell, there was a curl utility sitting for us to be exploited, and we used that curl, called the metadata APIs, and got the access token for that pod. And that pod had access to both production and non-production storage buckets with storage admin. So we had the read and write access. Now, again, interesting fact here was that while we were investigating why this sort of misconfiguration was existing or why it happened was the engineer team had an incident in the production, and they just for a certain period of time, they had given temporary access to that pod to talk to storage buckets with the storage admin rights. However, they did not revoke that credentials back, and they thought like it's fine, like they forgot to revoke it back, and that slight misconfiguration led to this storage buckets compromise. So we always need to make sure that the IAM controls are reviewed on periodic basis when it comes to the clusters and the cloud security. Now, all right, moving to the next attack. So I can go on and on, but due to time constraints, I'll be only talking 3 attack chains in details, but I have many more to discuss. I'm more than happy to talk in the hallway on the other attack chains. But for now, the third attack chain we'll be talking about container escape. Now, since I started doing offensive security engagements in the cloud space, container escape was always on my hit list, and everybody talks about it when it comes to cloud engagements. So container escapes and container breakouts, they're the most jazz words and most the Google words, I can say, when it comes to cloud security. People tend to do that. This time we got an environment to do that. So first thing first, as always, it looks super secure on the surface. There is nothing you can do from when it comes to your cluster like breakout or cluster hacking. But what we saw this time was that the task given to us was, from the cluster, there you're running so many pods and containers, can you break out of the container and access the host file system and also get a working shell on the node? Because the way Kubernetes works is you have a worker node, and then which is hosting all your pods and the containers running inside the pods. So we started with our standard process of reconnaissance. Again, in the cluster, there are so many pods, and then like finding that one pod which gives you access to your A or your task is always the hardest thing. And we were lucky enough to find that there was one pod running with the privileges of like it was running as a privileged pod, and the reason it was that it was meant to do because it was a security tool. It was meant to like collect all the metrics and everything, so it was requiring that permissions. But how we were able to abuse it, I'll show you in next slides. So that privileged pod was running it in the cluster safely and trying to do its job. But what we did, we saw that that's our window of attacking the cluster. We got a shell onto that privileged pod, and what we saw was the configuration that pod was running with. It was mounting the host file system onto the containers, and due to the misconfiguration that you're seeing on the screen, we were able to pull all the host file system on the container, and we had access to the entire host file system. And we were happily sharing this finding to the client, and the client said, please go away. He did not consider this as a finding, because he said, you are showing me the host file system, you're not showing me the working shell on the node. So it was like all our efforts went into some sort of drainage. But what we did was, we did not give up. We said, okay, let us try again, and we extracted the host file system onto the container, and we started looking into that host file, like what are the files we extracted from the host. And what we saw was there was a lot of KSA, like Kubernetes service account tokens we had captured from the host file system, and one of the access token that had permissions to create pods. That was the game changer for us. So what we did was, we used that access token to create our malicious pod. So whatever you're seeing in the screen, this is a suicidal bomb. Please don't configure this in your clusters. This was only meant to do a POC to break out of the container and have a working shell. So we did configure this pod with all the misconfigurations of the world, and we had a working shell on the worker node. And that's how, my friends, we were able to compromise the worker node and get access to all the pods and containers running on that worker node. All right, so as I said, I can go on and on because this is something I do on day-to-day basis, attacking Kubernetes cluster. So what we did was, like, what I've shown is you the details of the top 3, but the rest I can talk in the hallway if you want to, if you're keen to look into the details. Now, we'll move into the next section for our security champions, which is defense in depth, which is about how you safeguard your clusters. To make it simpler, I have divided the stages, so the application running on a cluster into 3 main stages, which is build, deployment, and run. And as the name says, the build is all about building your application code into a container and then pushing that container to a safe repository. And deployment is all about provisioning your cluster, how you provision your IAM roles and your secrets in the cluster. And the runtime is all about application running in your containerized workloads. So let's see, just conscious of time, I'll quickly skim through the key security controls, and these are not exhaustive, these are the most significant ones I have. In the build stage, you always have to make sure you scan your base images, because that's the pillar of your cluster, your container images. So always scan it for the vulnerabilities, and then you have, the next stage is to sign your images with a digitally signed tools, and then push that digitally signed and vulnerability checked images to your trusted container registry. Now, how do you do it? There are some tools you can see on the screen that can help you achieve those tasks. So that's the build stage. Then you have your deployment stage, where you deploy your cluster, and the most significant controls there are secrets management and IAM controls and network policies. So you have seen like how attackers are always after the secrets in the cluster, and also the IAM controls are always misconfigured because it's a beast. You can't go right on day one. So it's a process. So now how you achieve these controls are through the through the tools that are shown on the screen. So that's your deployment. Now, moving to the runtime controls, you have your security assessments. The periodic and the regular security assessments really help you achieve that runtime control. Then you have security policies. Security policies have to be in enforced mode. Please don't put it in audit mode. It does no good. I've seen most of the organizations putting security policies in audit mode. So please don't do that. Have it in enforced mode. Then you have runtime threat detection, like containers. You can run Twistlock or other tools in the containers that does wonders to the real-time detection of the attacks. So again, tools like shown on the screen can help you achieve that. All right. Thank you so much for listening to me. It was a roller coaster because of the time constraint, but I would like to conclude with key takeaways here. The key takeaways, for the attacking teams here is, please don't restrict yourself to attacking Kubernetes. Make sure you go beyond attack Kubernetes and look at all the integrating assets when you're attacking a Kubernetes cluster. Make sure you are focusing on the blast radius. Just don't look at the misconfigurations of the network policies. So what I like to call it as, so what? So if you have a network policy misconfiguration, go beyond that and find ways to exploit that network policy, of course, with consent of the client. For the blue teamers, the security champions, make sure you have defense in depth strategy. Every environment is different and every organization is different. Look at the risk appetite of your organization and have a defense in depth strategy in place. I have seen it works really well in the organization. And last but not the least, for organizations, always make sure that the first thing I would like to tell the organization is Kubernetes cluster is not secure by design and not secure by default. It has a lot of misconfigurations that could be exploited. So please come out of that confusion and then myth. And have regular offensive and defensive security assessments by trained security professionals. That's the key takeaways for organizations. And all right, thank you guys. That's for my time, and I hope to catch up soon with you all.